We can see stars through the moon. Watch the end of this video and you'll understand why we can see stars through the moon at certain times from different places that can be photographed and even observed with the naked eye. Now, seeing stars through the moon is nothing new. This has been observed by real astronomers for a few hundred years. But first, watch this person's 2015 moon eclipse of his observation of seeing stars through the moon.
On September 27, 2015, I took pictures of the eclipse of the moon. I set up my 5-inch telescope using a 17mm eyepiece and took these snapshots. You will notice in the pictures, stars show through the dark portions of the moon. And as I go through them, I'll blow them up a little larger so you can see these stars. I'll point to one. There's a blue star here, a white star. There's another star right here that shows up quite good. And that's that picture. Move on to the next one. You can actually see the stars here. Now we'll zoom in and we'll see a red star with a white star right in here. And then there's 3 stars, a white star, a blue star, and another blue star.
Before I explain how we could possibly see stars through the moon, let's talk about the electromagnetic spectrum. Here is a chart, and we can see that magnetic waves travel at different frequencies. Depending on the frequency, the waves do different things. All magnetic waves need a field to propagate through, or a medium to travel through. In other words, if there is no medium, then we would not be able to see. Scientists have held on to this belief that light is actually photons, which they've never seen under a microscope nor have witnessed. This is nonsense. All light is just a frequency wave propagating through a field. This duck is moving around, creating energy. However, the energy has no place to go since the duck is walking around in open air. The type of energy the duck is creating would need a different medium for that energy to transfer to. This is how light works. Light propagates through a medium. If we put the duck in water, you can see that the kinetic energy of the duck is creating waves, just like light waves. This is how light propagates through a field, much like the waves created by the duck. The moon gives off her own light. This photo here, taken over Russia in a high altitude balloon. We have the moon on the left side and the sun on the right side. Now, according to the heliocentric model, the sun is 93 million miles behind the moon. Therefore, it would be impossible for the moon to give light in the direction that the camera is facing. However, enhancing the photo in Photoshop, we notice that the moon gives a large, wide, circular, negative cold light, and the sun gives a very short distance light, or a spotlight effect. These two lights are independent of one another. This high altitude picture was taken about 37,000 feet. Well, you can see that the moon is extremely bright and illuminating the cloud layer below. Now, at 139,000 miles away, this would be impossible for this to be the reflected light rays of the sun off a rock. In fact, that's almost laughable. This camera had 2 filters on each side of the lens, and you can kind of see them here just a little bit. Something very interesting happens when the moon goes behind the filter. Now keep in mind, at 37,000 feet, our max view distance is about 5, maybe 800 miles on a good day. We can see the cloud layer illumination below, suggesting that the moon is only about 500 or so or closer miles away to this camera. However, when the moon goes behind the filter, we can see more of what's going on. As the moon goes behind the filter, we notice a few remarkable things. First of all, the illumination from the moon on the clouds below vanish because they are being filtered through the filter. The second thing we notice is that the moon becomes much smaller and causes a lens flare effect in the camera. For a lens flare effect to be caused by a secondary bounce light, such as the sun bouncing off a window, the surface of that object reflecting the light back from the sun would have to be extremely smooth or mirror-like. We know the moon, we are told, is just a rock hovering above us in space, and rocks are, well, they're not that reflective. This photo here proves that the moon is actually a projected light from somewhere above. And you can see that it actually looks like somebody is holding a flashlight, shining the light below on top of the clouds of the Earth. Now, this light hits our atmosphere, and that is the point of projection that we see from below. But also this light has to travel through something called Earth's electromagnetic field, and we're going to talk about that next. Earth has two fields, a positive and a negative. They comprise of our electromagnetic field that is on top of the Earth. As the moon moves across the Earth, the light has to go through one of these fields, the positive side or the negative side. If you view the moon from the negative side or the blue lines, then the image of the moon will appear reversed from the people viewing it from the positive or the red side. This is why somebody standing 10 feet away from you can see a slightly different moon, because they're standing slightly different in a magnetic field that covers Earth that is constantly in a state of flux and wavering around. This is why I believe it's possible that even though most of the time the projection of the moon appears as a solid and we can't see through it, sometimes as the light propagates through our atmosphere and through this field, that part of the image of the moon is cut off, and therefore we can see through the projected part of the moon, and hence we can see stars. I also apologize for flipping the Earth map. This photo, taken September 5th, 2018, from a camera zipped to prevent any image compression and checked for any photo editing software or overlay image using the camera. This photo is 100% authentic and legit. I checked Dave Marsh photos of stars as to what they should appear like through a digital camera, and I checked some other digital photos. These points of light you see shining through what we are told is a round rock are in fact stars. This one photo alone debunks the heliocentric model and is along the same lines of observation made by real astronomers, many times being scientifically documented years ago. Ladies and gentlemen, the Earth is flat.